Okay. So lean generally is about eliminate in Japanese muda, muri, and mura. So you will learn detail about lean in the lean class. And to do this, we have lean tools. And in that class, I will teach you further on the lean tools. For example, Pokayoke, SMAP, single minute exchange of die, visual stream mapping, and a lot more. But in this course, quality management, there is a chapter that I try to combine with Lean and Six Sigma. So this morning, I've explained to you about what is Six Sigma in general. Six Sigma is actually it's about robustness. Why Lean Six Sigma? There is a belting system for that. You can, maybe we have consultant or Liver Club, for example. They do training and certification for Lean Sigma black belt, yellow belt, and green belt. So the fee for black belt is quite expensive, same like your MABM class. So that is good. Why Lean Sigma? It is an improvement strategy. Then not just strategy. Remember PDCA, PDCA, but leadership must be here. Sorry for the bad handwriting. So your strategy you set here, and then you execute. You do. Then you check if anything wrong. Then you act. Plan again. Improve again. So why we do this? Because we want better business result. That's the purpose. And this is evolution of quality practice. In 1930s, as we know, Walter Sheward and also Dr. Deming, their quality those days was only on testing and inspection. Test, inspect, test, inspect. If your company just do inspection and testing for quality, that's 1930s. Then Dr. Deming, Dr. Walter Sheward, they introduced SQC, Statistical Quality Control. That includes SPC that we have learned before, Statistical Process Control. And Toyota introduced Total Quality Control. They produce car at lowest cost possible. They implement Total Quality Control, and that enables them to enter American market. And then in the West particularly, they will introduce just in time. What is just in time? What is just in time? This is when you follow you are in my class, I will always relate with the history. Although this is not history class, and also if I sit for history course, definitely I will fail because I have my memorizing capability is not very good. Okay. After Second World War, until 1950s to 60 in Toyota. After Second World War, there were companies in Japan that was identified helping the Japanese government during Second World War. They were listed by General MacArthur's government, military government by United States, and including central bank, all the officers in the central bank, especially the top officers, they were laid off, and companies that were involved in the Second World War were asked to stop their operation, and then that includes Toyota, because Toyota supply Hino truck for the Japanese army. If you remember from the movie, maybe the military truck used by by the Japanese army was made by Hino. Hino is the company under Toyota. For car, they brand it as Toyota. For heavy duty truck, they brand it as Hino. So that's Toyota company. So they were asked to close, but they have many employees over there, and it is the president's principle that employees' family is their family, is the president's family, so they will not lay off their family. They should be together. So they have to find ways to get money to pay salary and to make sure Toyota still survive. And because of the inflation was very high, many people don't have home, don't have houses, don't have shelters. They live at the street. They're very difficult to get food until, as mentioned by Akio Morita, Japanese after Second World War, they work only for a bowl of rice and some soya sauce. That was only their salary. They work with Akio Morita, Sony, only to get a bowl of rice and soya sauce to feed the family, until to that extent. So you can imagine the situation those days. Actually, I have a video. The video you cannot find from the movie shop because it is made by Toyota and it is sold in the Toyota Kaikan Center in Japan, in Nagoya. I bought that video. There is 2 volumes all about how Toyota began, and then until they have problem, crisis, and then they rebuild, gear up the business. Okay, we go back to Toyota. So in order to survive with the money that they have to find ways how to expand the money. The idea is, with the money that we have, this is money, they get orders. They get order from customer. They get orders, then they build car. They build car. Then sell to customer. Get money again. This money, top up here. And then some they used to pay the salary of their workers and order again. Order based, they make by order. So this was the principle of just in time. Just in time. Just in time. Because survival. You want 10 car? Okay, give me the money. I built 10 car for you. Then this is your car. So I got the money. That was the business after Second World War. So with that, they have JIT. So ideally they expect JIT, one piece flow processors. They get order, go to the system, set the bill of material, set the kambang, set the anything, then pass to the supplier. Supplier send part. So parts arrive to factory, straight away assemble, then ship straight away. That's the idea of GIT. But as time goes by, they start to improve with the Kaizen approach, and then they also have some inventory, minimal inventories. But they calculate their inventory, not just simply put the inventory. So they know how much is the economic orders quantity and so forth. But again, Idlan, we went to the factory, I show you lot of inventory. Am I right? And the inventory was not organized at all. It's horrible.
It was near the line.
Near the line, boxes, unnecessary items also there, rubbish also there, empty boxes also there. Oh, horrible, eh? But that is Japanese factory, very popular brand. Okay, that's on the GIT aspect. So, Dr. Feigenbaum introduced total quality management. Then, in order to integrate all the standards all over the world, ISO introduced ISO 9001, business process engineering. Then, people from Toyota, they went out from Toyota, they introduced lean manufacturing, Six Sigma, then combined lean and Six Sigma. This is kind of evolution of the quality practice. So what is Lean Sigma approach? It is not just Six Sigma. Six Sigma introduced by Motorola and General Electric, sorry. It's not just lean, but it's a combination of these two elements. It's not about Six Sigma first, then lean. It's integrated. That is Lean Six Sigma. However, in Toyota, they have Toyota Way, they have Toyota production system. They didn't highlight Six Sigma, but actually their process is world-class, is better than Six Sigma. Maybe Seven Sigma. Because I would like to cite my friend's statement, Kitahara-san. He is from Denso. Denso is actually subsidiary of Toyota. At one time in 1950s, they were together. You know, in 1950, Denso and Toyota, they produce their electric car. But the weakness of Japanese is their self-confidence is not as high as Westerners or Korean. So they like to keep their innovation in the museum. So they kept the electric car since 1950s in their museum. Same goes to electric power. Long ago, they have built a system, LED system, to light entire building using AAA battery. Sorry, AA battery. But they never announce it to the market. They never sell it in the market, but they just keep in the museum. And then suddenly someone overtake them. Electric car. Started by Toyota, but Toyota is not very popular with the electric car. Although they have hybrid car. Toyota Mirai. That's the weakness, I think. Okay. What happened to connection? Wait, I reconnect. Um, in Six Sigma, it must become with vision, of course. What is the vision of Six Sigma? It's on operation excellence, but I want to emphasize on this improvement technique, DMAC approach. This is Lean Six Sigma approach. We call it DMAC. I think some of you may be familiar with this. These are the steps, the process. We start with define, then we measure, we analyze, we improve, then we control. And the management structure for Six Sigma, as I mentioned before, start with teams and then certification for green belt, certification for black belt, and teams sometimes they have green belt, yellow belt, sorry. They have belting system. And then the highest one is the champion. So what is the operating philosophy for Lean Six Sigma? This is in line with the quality improvement purposes to reduce process variation. This DMAC approach is to reduce the process variation and then to improve the process capability, CPK and PPK. Why we want to improve this? Because we want to get the Six Sigma capability. And definitely money is more important, so lower cost of operation. Lower cost of operation. I would like to ask you. Normally I ask in the beginning, but I've forgotten to ask you. Between cost and quality, which one is more important? Okay, I want to ask one by one. Is that Idlan? Which one important? Cost, quality?
Quality.
Quality. Okay, Jack.
Quality.
Quality. Sharinon.
Cost.
Oh. Jeffrey. Jeffrey.
Quality.
Quality. Hidayah.
Quality.
Peter.
Quality.
Amira.
Cost.
Izati. Izati. Are you there? Kantoi. Izati not there? Okay. I want to ask Amira, why you say cost is important?
For me, if I do in business, I can give you a same quality, but in maybe lower cost. I mean a lower price. It means that I keep the cost low, but give the same quality.
Okay. Peter, why you say quality is more important?
The good quality will make the cost will down.
Okay. Sharino, why you say cost is important?
Because like Amira, I can produce a good quality but lower cost.
Ah, tricky. Good quality at a lower cost. Toyota, their target is to produce high quality car at lowest cost possible. So which one should come first, quality or cost? We have to go back to this perspective. Jidosha, that is a car maker. I'm talking about Toyota, because this color also Toyota color, my pen, red,
Right.
and consumers. These two parties, what they are looking at?
Quality.
They are looking for value, actually. Am I right?
Yeah, value.
So what is the measure for value? Is yen. Ringgit Malaysia. Ah. So that's the measure for value. They buy high quality product, robust product, so they can use it longer. And the second value for car is better. So they are talking about value. When quality problems happen, loss to society, mentioned by Dr. Genichi Taguchi, is related to money. Remember, quality loss function. Sorry, bad drawing. Okay, quality loss function. So this point, at this point, is the ideal one, zero cost. Loss, and zero loss to society. So if it is deviates a bit, there's a loss to society. But as long as it is in between limit, we can manage the loss. But if it is beyond this, loss is bigger. So Dr. Genichi Taguchi also emphasized why they want to improve the robustness for quality improvement, because they want to prevent loss to society. Although quality is important, but the objective of the business, the objective of the customer is money. That's the purpose, is cost. And quality is a vehicle, just a vehicle. The vehicle to get cost reduction, to get the value. That's the reason. It's like chicken and egg, but we look at the purpose. Purpose is value. We always talk about value. Why you buy kind of expensive gadget? Because you talk about value, you think about the value. Value is money, but that value is delivered by the quality. So Dr. Genichi Taguchi, this is not my question actually, but Dr. Genichi Taguchi question, and then he was transferred to his son Shin Taguchi. He always asks the audience, which one is very important, cost or quality? Definitely, majority of the participants tell quality is more important, but quality improvement can have cost reduction, but the objective is cost, quality, money. Okay, is that answer your question? Is that clear?
Yeah.
So everything
The right one, quality or cost?
Cost. From the quality loss function, this one, it shows cost is important. The objective for quality improvement is to reduce cost. Objective of quality improvement is to reduce cost. Why? Because we want to give value to customer. Value. Okay, is the answer, Shariron?
Yeah, clear, Prof.
Clear? That's why you are in the business, because of the value. You produce high quality for no reason, no point. Even Kaizen activity, Kaizen. We attended a training in Nagoya, in Toyota. And then the sensei gave us a problem to solve with the Kaizen. Definitely, maybe because we are Malaysian, I think, when we propose for the Kaizen, we give kind of sophisticated ideas, which require money. But the sensei said, dame, dame means never, no. Why dame? Because the philosophy of Kaizen in Toyota is to use available resources, not to spend more money for Kaizen. We use whatever around us for Kaizen, for improvement. So it means with Kaizen philosophy, we get money because of cost reduction. This morning, my student presented her MP project. She managed to reduce cost about 37% to the company from her master project. That's my expectation. When students come to me, they want to do master project under me, okay, must relate to your company. What your CEO want, that's what you should address. Not just academic research and then doesn't give anything to the company. Anything you want to do with me must relate to your company. Okay, must use available resource. So we get money because we reduce cost, but no modal. No what in English, modal?
Capital.
No capital. No capital. That's the idea for Kaizen. If Idlan remember, when we were in the company, we were in the factory, I always mention that, right? Do Kaizen, less capital or zero capital. That's the target. If you want to do Kaizen, then you request budget, extraordinary budget from the management. That's not a Kaizen. That's a rubbish. Okay. What is the Six Sigma principle? To reduce variation. The principle of Six Sigma is to reduce variation. Sigma capability of process performance measure compared to the voice process with the voice of customer defines as follow. Number of sigma between center process performance measure distribution is the near the specification limit. Okay, this is 3 sigma. 3 sigma. So we improve this to the 6 sigma. We squeeze this. So when we squeeze this, you will see that this peak increase, means the density increase. Density increases. So by having this, we can reduce the variation. In the process, there are a lot of variation. In any processes, there are variation, a lot of variation. What is the variation? Variation due to noise factor. Noise factor. Remember, injection molding. This is a die barrel. Screw inside there. We put the resin here, inject. Temperature is the control factor. The pressure, control factor. The speed, metering speed, that's the control factor. Maybe the mold temperature, that's the control factor. And what other? These are control factor, CF. Noise factor. Noise factor will result to the variation. For example, maybe environment, ambient temperature, maybe noise factor, or maybe more clamping, how long it clamp, maybe more opening speed, or whatever. Anything that prevent the successful of the process, we call noise factor. Anything, any variable that is needed to make sure the process is success is the control factor. So the interaction between control factor to the noise factor, if we can optimize it, will give us the robustness. When it is robust, the variation is reduced, then we can improve the process to Six Sigma. Here, written. Excessive variability in the process leads to the process not being capable to meet customer requirement because the process is not robust. This is another example. Cycle time for taking X-ray at the hospital. They recorded the data and then they have the histogram here. From maybe more than 0 minute, maybe 5 minutes to 50 minutes. So we use the probability that we have learned before. So this is what customer wants. Maybe this is our promise to customer. Maybe 2 hours, for example, maximum the turnaround time. So if it is more than this, it's defect. So we can use the probability that we have learned this morning. So the purpose of DMAC approach is to reduce the variation, the variant become like this, and to ensure this tolerance. How to make this happen is Six Sigma. So if anything happen, maybe it shifted to 1.5 sigma, so we still have the tolerance, so the customer will still satisfied. So that's the idea. So how to do this? Minimize variation. So if we minimize the variation, we got less defect, so we have better capability. This is Six Sigma by Motorola. 3.4 defect per million is Six Sigma, but by statistician is 0. But Motorola still give one leeway based on 1.5 sigma shift, they put 3.4 defect per million. But according to my friend Kitahara, he says that if in US plant, if there is 1 or 2 defect per day, is okay. The plant manager still can drink beer in the bar. But in here, means in Japan, if there is 1 defect per day, the plant manager will have sleepless night. So imagine. So Japanese expect not 6 sigma, but 7 sigma. 7 sigma, according to Motorola, is 0 defect. So how do you achieve this? Hours, I don't know. Maybe to achieve this is good enough, but in average majority company, I think it's very hard for them struggling to get 3 Sigma.
Prof, when
Yep.
we look on this the Six Sigma again on the percent of good.
Hmm.
For example, our telecommunication, they offer 99.7%.
Hmm.
So, but if looking on the Six Sigma on telecom unified
Hmm.
measurement, 99.7%, it means that
99.7 is around 4 point something,
4.2 sigma.
just above average.
Is that true? They are calculating sigma or they just make up?
I think they based on their capability today, but they are targeting for that to improve their Sigma. I don't think they are Six Sigma. Hello?
Yeah, because of the looking if we use Uni5,
Hmm.
3 problem a year, for example, right?
3 problem a year out of how many
300
million?
per user is 3 problem for one user, 3 problem a year
3 problem a year for one user.
for one user.
So how many users they have? So from there we can calculate the Sigma level. We can use DPMO formula. I don't think that is Six Sigma. Okay, if we are at the 3 Sigma level, 3 Sigma, the economic level proposed by Dr. Deming. If it is 3 Sigma, means what? 95% compounded product, first pass yield, 3 million pound of rework every week. 90% on delivery means 1 missed shipment every 30 minutes, 3 Sigma. Billing accuracy, 3 billing error every 3 hours. 20 million pound of lost opportunity. This is 3 Sigma. And when we have defect, we have to redo. That's a cost of poor quality, as I mentioned in the earlier class. This is the cost of not doing things right at the first time. Cost of poor quality, rework, work in progress. That's cost. So we have to avoid this. And this is very dangerous. Lost customer goodwill. It's happened to one company because of just power window problem. And this is a cost of poor quality, as I mentioned before. As you see here, it's hidden in direct loss. You thought that by a redo, recheck, you can solve the problem. But how about this? We never know. And if you can improve this, you can improve your opportunity to increase the profit margin. Remember from my slide last week, I'm talking about price, non-value added and value added. If we can eliminate the non-value added, we can reduce the price. And this is Six Sigma improvement management. Same like total quality management, it should, in the company wide, it should start from the top management. And the senior management has to address this. And these are the enabling skills for Six Sigma. Of course, they have to be able to do the DMAC approach. Data analysis skill is needed. Process mapping, analysis redesign skill, and team working also important. And what else? These are maybe among projects that you can do in your company for Six Sigma activity in order to give profit. If you want to do on cost management, increase sale, improve work capital, and these are among the projects that can be done in the company. And these are the measures that you can use for your improvement. This is your yield. You want to improve all this. And dashboard, what else? This is case study, Commonwealth Health Corporation, non-profit organization. You have 3 medical centers, around 2,000 employees, annual revenue 350 million. This is a goal for the improvement activity. Effective use of financial resource, organization excellence. This is how the Six Sigma started. They have identified 4 priorities for Six Sigma deployment: to improve customer satisfaction, quality of service, timeline, speed, convenience, and cost. So, project example, reduce time between project detection report signature, reduce special waiting time, enhance radiology, decrease MRI turnaround time, operation room suits turnaround time, this being done also by KKM Malaysia. Reduce time for holding to inpatient and outpatient surgery, also done in the hospital in KKM Malaysia as well. They have Six Sigma team, Lean Six Sigma improvement team. Improve accuracy in charge capture in outpatient, reducing CT order to time taken and so on. As you see here, Six Sigma benefits, it shows the cost reduction. Cost reduction. For that case here, in this case, medical center, after they implement Six Sigma, the benefit increase, but the cost reduce. Benefit increase, cost reduce. So this is a good thing for the management. And this is a phase for Six Sigma. We begin with define what we want to define. In this define phase, the objective is to identify what we want to do and what are the opportunity. Maybe we can do the SWOT as well. Identify what are our SWOT, and then what is our strength to overcome the threat and weaknesses. What is our opportunity to overcome weaknesses and threat? So then they manage to define focus area, set up project, deploy team. When they have team, started the activities. Under measure, they determine their capability. So use the data that they have, maybe plot SPC, maybe. Then from there, they know their capability. That is the state, the current state, the capabilities. And then they have to define what they want to improve. And then develop data collection plan. Determine process system capability, CPK. Then in the analyze, you have to investigate the cost. Maybe you can use 7 tools or 7 new tools. Find out the causes, verify the causes, and then also with the tools, we can find solution. That's the improvement. What is the solution that we want to make? And then we plan the improvement action. Then we implement it. We have to verify whether it's improved or not. Then after we have done this, sustain is very important. Otherwise, it will be back to normal. So sustain part, same like 5S, the last one is a sustain. So this is top management role. So we have to have the documentation. We have to make sure the action, standardized improvement action, documentation is very important. This is among Six Sigma activity. And this is a tool that we have used, and I think this is QFD. We have learned yesterday, fishbone diagram, and etc. So everything we have learned in my class. These are graphical tool, data collection plan, hypothesis testing, correlation, design of experiment, control chart, and etc. Those are Lean Six Sigma. And this is about Lean. I think I've covered Lean before. So I think I have done for